Yeah, so a lot of you, I've had a lot of you come up to my hours and ask me about tension, and when I've explained problems dealing with pulleys and stuff, why don't I address tension? As I've been solving problems for a long time for physics, and I can tell you, as a general rule, I don't even think about tension unless they're specifically asking for it. Okay? I don't even think about tension in the first like 5 steps of this problem. I don't even care about it because I know I'm going to get to it. You'll see what I mean when we solve for tension. But initially, all you need to worry about is how there's a force of friction and then there's a force of gravity pulling down. Those are the 2 forces that are really doing anything. Tension, side note. I don't care about it, not until the end. Okay? Cool. So, force of friction is going to be the normal force times this. So, this is going to be 49 newtons, 9.8 times 5 kilograms, 49. Then, multiply by 0.2, and that will be something. Huh? 24.5. I have F net written, but not that for some reason. Okay, so then we also have Fg, which is 9 times 9.8, and that is 88.2. Are you sure it's 24.5?
No,
It's 9.8, I'm pretty sure.
9.8.
Yeah. Okay. Yeah, force of friction. I think it was 9.8. So the F net, with all pulleys, no matter what angle they're at, if it's 90 degrees, if it's at this crazy degree, right? All pulleys can be seen as basically a tug of war of forces. You have force of friction and Fg, okay, where Fg is a lot bigger. Huh? Yeah, force of gravity. Force of gravity is on the 9 kilogram. This is the 9 kilogram box. This is a 5 kilogram box. Okay, force of friction. So basically, you take this big old vector and you subtract this little guy to get F net. That's what you want to do. You want to get F net. Okay?
Can you just go over real quick one more time how it's 9.8? I know you just said.
Oh, this is 9.8?
Yeah.
Yes, absolutely. Okay, I'll just write it down for you. Force of friction is equal to 0.2.
Okay.
I'm going to write it. I'm going to do it opposite order. There's the answer. Here's the equation. Here's the variable equation. UK times F of N.
All right.
0.2 times 9.8. 98. No, 49. 49.
Okay, that makes sense. Okay. That
Right.
corresponding with gravity just confused me.
Yeah.
Okay.
When just something's sitting on a surface,
I got it.
you're putting a pressure on it. it's
I just
putting
wasn't
a
sure if you substituted gravity or if you actually calculated it out. You
I
calculated it out.
I count. Yeah, no. Well, 5 and then
Yeah,
multiply
okay,
something by
okay.
5 and then multiply by 0.2. Guess that. 0.2 is 1/5. So.
Gotcha.
Yes.
Sorry, wasn't there an equation you had up just a minute ago?
What? I had a tug of war thing going on.
Oh, okay.
Yeah.
Never mind.
That was just an example.
Never mind. Sorry.
Yeah. No worries. All right. So yeah. So force of friction is 9.8. Force of gravity is 88.2. So F net is equal to 88.2 minus 9.8. Right? Got 88.2 pulling it down here and to the right here, and the force of friction is opposing that motion. So that means it's going the opposite way, so you subtract it. So the net force is 78.4. Cool? Now, F net equal to ma. So in this system, the acceleration of the whole system is A, and then the mass is the mass of the whole system. Okay? So this acceleration applies to how fast this guy is going down and how fast this guy is going over. So therefore, we know that this is equal to 9 plus 5 kilograms times A. So that ends up being 14. So acceleration will be 5.6 meters per second squared. That's how fast this guy is going down and this guy is going to the right. Okay, so now what do we do to find tension? Okay, now that we found the overall acceleration of the system, how you solve for tension is, and this works without fail, by the way, you solve for the F net, then you solve for acceleration, then you isolate one of the things going on, okay? You isolate this, I'm going to isolate this guy because I already worked out the numbers for it, okay? So, but it'll work for this one too. So now we have F net of the 9 guy, okay? The F net of the 9 guy is equal to, where is it? 50.4 newtons. Take 9 times this acceleration, so above it I'm just going to write it, 9 times 5.6 is equal to that, right? And then you can set that equal to mg minus tension, right? 50.4 newtons is going to be equal to 88.2 newtons minus this tension, because those are the only forces acting on this guy. The F net is this because you take the mass of this one guy and this acceleration applies to both of them, multiply it, and then these are the only two forces acting on the 9 kilogram is the tension and gravity. If I were to do the same, I could do the same for F net of the 5 kilogram guy, and that will be equal to tension minus force of friction. So multiply 5 by 5.6, right? 56, 28. 28 is equal to tension minus force of friction. And from this equation, we already got the tension equals to 37.8. It works out. It works out for both of them. So you want to find the overall acceleration, because this acceleration will apply to everything. Then isolate one of the systems, and you see how tension is one of the forces of the system. And then you can go from there. Yes?
What did you do, 50.4?
50.4 is this 9 kilogram. I found out what the F net of just the 9 guy is. Okay? So F net is MA, right? The mass is of, and we're dealing with only F net of the 9, so it's just 9 times the acceleration we already found. This acceleration doesn't change just because we're isolating the system.
Oh, so it's not divided by that.
No, yeah, this isn't equal.
Big deal.
Equals, do you want me to just like, I don't know what you want me to do. Got it?